let's take a look at this first problem. Okay, log base 2 of 2x plus 1 is equal to 3. So step 1, get your log completely alone on one side, which is done. Step 2, rewrite its exponential form. So we take the base of our log is the base of our power, or our exponent. So 2 to the power of 3 is equal to the expression inside the log. And then solve this resulting equation. So when I solve this, 2 cubed is 8. It's equal to 2x plus 1. Subtract the 1 from both sides. And then solve. 7 divided by 2 is your solution for x. And you do want to check your solution. Just make sure when you plug it in here that you don't get any negatives. So here we take 7/2 times 2 is 7 plus 1 is 8. 8 is 2 cubed. The power of 3 can be moved out in front. Log base 2 of 2 has a value of 1. So 3 times 1 does equal 3. So it does check. Okay, so here's one where you actually do perform that first step. You look to condense this into one single log or simplify what you have. Well, the way that I'm going to simplify is I recognize that this 9, can it be expressed as in terms of an exponent with the same base as the log? 9 is 3 squared. So this power of 2 gets moved out front. And then this log base 3 of 3 has a value of 1. Okay, so I'm simplifying my expression first. I'm going to add 2 to both sides to get my log completely alone. Log base 3 of x plus 4 is equal to 2 plus 2, which is 4. Okay, so once again, I could either move this 2 inside my log, or I can do what to both sides of this equation? If I divide both sides by 2, it simplifies it, gives me smaller numbers to work with. So 4/2 is 2. So I get this log base 3 of x plus 4 is equal to 2. Once I get it into this form, I can rewrite the exponential form of it. Base 3 to the power of 2 is equal to x plus 4. Solve what I have. 9 is equal to x plus 4. Subtract a 4 from both sides, and I get x is 5. Okay, double check it to make sure that it works without giving you a negative inside the log or as the base of a log, and 5 plus 4 is 9, so it works just fine. Okay, and so this is your solution. Okay, so here's a case where you do want to condense these. You can either move them into one side of the equation, set them equal to 0, or better yet, 1 log on each side of the equation. Okay, so if I can condense the left side into a single log, any factors that resulted from a positive log are factors of the numerator, so x minus 1 fits that category. Any factors that are part of a negative log are factors in the denominator of our overall expression when we condense it. So here's our first log, and we can condense the second side, the right side, into a similar form. 1 log. The factor x minus 2 originates from a positive log, so it's a factor in the numerator. The factor x plus 3 originates from a negative log. That means it's a factor in the denominator. Okay, once we have these set equal, we can simply equate our values inside the log and solve the resulting equation. So when we work to solve this, okay, it is a proportion. And you can treat it as any rational expression or equation and multiply by the LCD, but you can also just cross multiply here. So we get x minus 1 times x plus 3 is equal to x minus 2 times x plus 6. And then if we FOIL here, we get an x squared, a plus 3x, and a minus x. And then finally a minus 3. And on the right side, we get x squared plus 6x minus 2x, and then a minus 12. So if we combine these, here we get x squared plus 2x minus 3 is equal to x squared plus 4x minus 12. And we can go ahead and combine all our like terms. So we subtract an x squared from both sides, move our x's to one side, so subtract a 2x from both sides, add our constant, or move our constants over to the other side. We get negative 3 plus 12 is 9, and now when you isolate your x, you get your solution 9/2. So once again, if we wanted to, you could test it back into these expressions. All you really need to know or make sure is that you don't get negative values inside your logs. If you have time, plug it in. If not, again, the 9/2 is the correct solution for this problem.